Hello, everyone. Uh, if you want to start making questions and you feel more comfortable using a mobile, so you can use Lido, which is pretty cool. So just feel free to do any questions, or we're going to have a Q&A session afterwards. But if you feel more comfortable, just you have to just connect to the website lido.com. PBD, which is privacy by design, is the keyword for accessing this specific talk. Okay, so let me switch. Let's go. Okay, now this is going to be an interesting, I think, talk. I'm going to kind of introduce somehow what machine learning can do for privacy. I see privacy as a sort of extension of security. I think they're not different concepts. They're very related. So I'm going to try to explore pretty much what is privacy from the application sec perspective, which is typically called privacy by design. Okay, so just if you feel free to interrupt me, just raise your hand. Let's make it kind of two-way as much as possible. Okay, so let me see if this works. I'm going to try using this device. Just one sec. Okay. Okay, it's not bad. Okay. So that's pretty much what I'm going to do. This is not an awareness talk. There are many. There have been a lot of sessions about privacy awareness, like what should you do with privacy, but there's very little, at least to me, very little content about what can you do now, okay? So I'm going to try to introduce at least what I've been researching in the past couple of years. Second thing, I believe in a totally development-centric approach towards privacy. Right now, privacy is more like kind of top-down. You have compliance people saying this is what you have to do, and it's not even very, very, let's say, specific. So I believe in what I call, grassroots approach. We're gonna explore that a little bit more. And then we're gonna see one way. Privacy is a huge space. So we're gonna, I'm gonna kind of share with you guys what AI can do for you, and it's not so. Let's call it AI can seem like very challenging to approach, but right now the technology is kind of picked up, and it's more. Let's call it. It's easier to implement solution on top of that. So you can do a lot without having to, to build or to buy, the latest product. So let me keep going. So I'm kind of, pretty much I see myself as a developer. I started as a developer, and even if I run my company, I still keep development. Okay, so that's the way we typically do research, and I'm still very hands-on. Okay, so at my heart, I'm still a software developer, which is, love security. And I see privacy just as something even to me that I feel it's very important, at least. It's something that is affecting our personal lives. So if I can contribute something, that's great. So, well, my first computer was Commodore 64, so I'm old. Okay, I'm not sure if anyone here knows Commodore 64. You had a prompt and you had to just write BASIC. That's it. So let's keep going. Well, this actually, I have no comments on that. It's a very, let's say, vague, very generic, but it still applies. For instance, where I live in San Francisco, I've just once looked up my name in Google, and I found that there was information about my house. So my house, it was linked with my identity. So, and I never share that information, okay? So I feel, very annoyed when these things happen. You find really personal information online, okay? So it's not just easy to fix that. Now we're gonna see why it's not so easy. So a few years ago, there's this professor, Cavoukian, introduced a concept called privacy by design. So let me start using this, okay. Which is, I think those principles apply to security too, right? You want to anticipate yourself to any privacy issue, so that it has to be preventative, not reactive. And privacy as default means that it's actually more at the consumer side. It's basically, by default, disabling, all the features that can compromise the consumer privacy. For instance, if you download an app, typically all the privacy settings are against you. And you have to go to the settings and say, no, I don't want to share this information, and so. So that's privacy by default, okay? So that I think is really important. But my focus today is going to be on the privacy embedded into the design. Now, it looks like I lost my, let's see if it works. So, and the other concept is that full functionality. That means that if you, for instance, are using a VPN or, let's say, an anonymous browser session, you don't want to lose any, you want to just stick to the same user experience. Sometimes, when websites or applications detect that you're, trying to protect your identity, somehow the whole user experience changes against you. So that's pretty much what we mean by full functionality. End-to-end, it means that, you have, privacy has to be bundled into the whole SDLC, the whole software development life cycle, and not only your own, but also beyond the perimeter. That's pretty challenging, right? And I think visibility and transparency, it's pretty much respect for user privacy. It's the same thing to me. Okay, so if you consider privacy as first-class citizen, you're going to get all these attributes, quality attributes. So let's see if at least this works. So this is data, at least I have from 2017. So this is all, I think, has been even worse. Okay, so but this is just an idea of what is the financial impact in privacy. I don't want to get too much into this because a lot of there's a lot of information about this, and there have been few significant breaches, the past couple of years, like Equifax, and there have been a couple more. So we're gonna, but this is an idea of the financial impact. I think it's even more significant. It's very difficult to measure what is the business impact when you get your personal records leaked or some sort of leak in terms of personal data. And this, we go back to the same to the original concept I was trying to explain before. Why is it difficult? Because it's totally ubiquitous. It's not on infrastructure. You have to do it end to end, as I said before. You have to actually. It's not only what happens within the perimeter, but also outside with your service providers. You don't really know what happens when you send personal information of your users to, I don't know, a service provider like Google, Amazon, whatever. How do you make sure that they're protecting this data? Okay, so that's very, very challenging. Even if you do a really good job at protecting the data, you will never be sure about that. Of course, there are legal things you can do for that, but it's just a legal framework. Okay, it's not a technical countermeasure. And the other thing is that I think that privacy itself, pretty much all the content I see is very high level. It's difficult to put that into something that works. It's just saying this is what we should do, and you get there are many vendors providing some very niche solutions. But what can I do now, right? And that's what I feel it's just privacy by design. How many people know the term privacy by design or PBD? here. Cool. Okay. Oh, we got a few people. Okay, that's great. The other thing is, the other thing is lack of, okay, there are no tools, very little tools. And if you want to, there are some tools, but are coming from startups or large corporations. Some are based in Silicon Valley, but I believe that that's, the mindset that the tool will be the solution is very dangerous. Okay, as in security, there is no perfect tool. It's a combination of tools plus your know-how, and plus the, kind of your expertise about what you have to protect in terms of how your business works. So I honestly believe, even if I work and try to create technologies with my company with in terms of privacy, I don't believe tooling is the problem. Okay, it's just part of the solution, just part. And I think this is also applies to security. And typically, management it's application security. It's somehow it's more known because it's older. But privacy, application security is a very new subject, very new topic. So there's not a lot of information, and so it's difficult to get funding. It's difficult to there's an effort in evangelizing the management. So I'm going to introduce something a little bit controversial here. So what do I mean by grassroots adoption? I mean that as security guys, okay, there are a lot of, I've heard that there are a lot of cybersecurity people here. You want to, you can actually start bundling privacy capabilities into your infrastructure right now. And I believe that you don't have to wait for, upper management to tell you this is what we should do, and that's going to be probably too late. Okay, so what I'm proposing here, it's more like what is called the cathedral and the bazaar. That's a typical book paper that pretty much explains how the Linux software development process worked. And Eric Raymond is actually one contributed to one of the core pieces of not the kernel but the standmail, but he pretty much explained how that works. I believe that bringing all that, let's say, model to privacy, at least in protecting personal data, in the application, I think it's a very healthy approach. And as you can see here, it's you can pretty much use techniques that are available in existing software security testing. Okay, so static code analysis, dynamic code analysis, it's not very different. So what I believe in is that you can start introducing those capabilities incrementally, because to me, privacy is security. So if you're responsible for security, you can also, and you should, I think, that's what I believe, start caring about privacy too. How the application is pretty much handling personal data flowing through it. That's when I say. That's privacy by design, pretty much. So here, this is a kind of head-to-head comparison. Okay, right now, pretty much the process that is described that people, promote is the first one. Policy, what I kind of call policy-driven. So there's a change in the security policy or a security architecture or something, that kind of goes top down to developers or security architects. And that process can take a lot of time, okay? And I'm not saying to discard that, but what I'm saying is that kind of to start doing something right away as part of the security efforts, okay? So that's why the main difference is engineering-driven, versus policy-driven. These are all concepts coming from the, this cathedral and the bazaar, kind of approach. The other thing, as I mentioned before, you can build on top of your existing capabilities. So the techniques used for doing PII detection, so detecting personal data are not very, very different. So it will take some time, to kind of walk the learning curve. But at least, the techniques are not very, very, very different. And the other difference is that, typically, pretty much most vendors, they approach the problem from the data perspective. That means that they scan your repositories and look for PII, personal data, and they kind of flag that. I think that's very limited because before the actual data goes to the database or some repository, a lot happened. And typically, the application is in front of that, okay? So if for some reason personal data is being leaked for some, whatever, bug or on purpose, who knows, you're not going to know. So I believe you do have to protect, your infrastructure, your databases, whatever, but you also have to protect your software as much as possible. And make sure that the software used in the cloud, which is something very different, is also has some privacy quality standards. So it's very difficult to know that actually. The other thing I'm suggesting, which kind of goes against my interest a little bit, is try to build your own stuff. You can mix third-party tools, but try to build your own stack, because every company is different. There is no silver bullet, okay? This same thing, I think, applies to security. At least the companies I know I work with, they all have their own stack, to deal with security. I think same thing should happen with privacy. So this is a kind of, instead, just I was at like 10,000 feet. Okay, so let's go a little bit deeper, okay? So let's, this is one of the concepts we've explored. I worked directly with that, but it's just one of the experiments, okay, that we eventually, the experience from all these prototypes eventually gets into the product or whatever. But this is something we've open sourced, and it's something out there you can play with, kick tires, do whatever you want. It's just something as an example that there are things you can do with not so much effort. So the main things, with PrivAPI, what is PrivAPI? PrivAPI is basically geared towards trying to detect personal data flowing throughout your API endpoints, okay? So any personal data flowing from let's say, a web service, okay, should be and can be detected, okay? And at least you should know. And this, what I believe in is kind of to apply this strategy while the applications are being developed, not only applications in production. So as you're developing application, you can start checking whether there are applications that are just transmitting personal data in clear text, okay, for instance. So as soon as you start with your development cycle, you can introduce this kind of practices. So these are kind of the challenges. There was no data set. When you have a machine learning model, you need the data. Data is kind of the key thing. At least this is what has been my experience. So if you don't, how can you teach the machine to pretty much know what is personal data and what is not, right? So this was one of the issues. Of course, there are no standards. I didn't want to introduce an approach where you have a human being kind of labeling and say, yeah, this is private, this is not. That's a lot of money. That's too expensive. And of course, PII is not out there online, right? You cannot find easily social security numbers. I mean, you can if you want, but I mean, it's not legal, right? So that's pretty tough. So, and of course, there are practically, at least on GitHub, very few projects dealing with PII, okay, or something that's related with privacy, kind of that works. So it's kind of, you're pretty much alone, okay? There's not too much on that front. Just several commercial products, but you don't have the source code to learn from that, okay? So this is high-level architecture, but we're gonna kind of split it, okay? It's gonna be clear as we kind of split it here. So let me check the time. I don't want to run. Okay. So pretty much, since we don't have the data, there is a technique in machine learning. It's called, which is basically generating your own data set. Okay. The problem with that is that the data set will be probably biased, will be artificial, and will not match real-world data. Okay. So it's a very, you have to be very careful with that, because if not, it's not going to work. Maybe it works with your test data, but then when you run it with real-world data, it's just not going to classify correctly, any RESTful API message. So this works pretty much in the following way. So what we essentially did is, in order, we wanted to generate the example API request, RESTful API request. So pretty much JSON payloads. Okay. So the way to do that pretty easily was to kind of tap into existing RESTful API infrastructure. So instead of sending the message throughout the wire, we can just save it, right? We can tap into the request generation process, and we can just say, okay, we're not going to send it throughout the wire. We're just going to save it, okay? So that's pretty much the approach. Now, with the data, it's not enough. You have to actually define what kind of, whether it has PII or doesn't have PII. Okay, personal data, pretty much. PII is personally identifying data. So that's why you have, we use a very basic approach, and there's a lot you can do in terms of improving the labeling. So labeling is that. It's saying, okay, this is PII, this is not. And for now, it's just binary. But you can have many different labels, like this is PII, this is financial information, this is healthcare-related information. And there's a lot you can do on that front, okay? We're going to explore a few strategies at the end. So bottom line, we have these requests. We label these requests, and then there was a challenge here. Let me go. I explained the flow here. The problem was that what we used as an input were open API descriptors. So how do we know how requests look like? So the good news is that open API descriptors are actually available online. They're pretty good quality. So with that, we can build pretty real-world looking API messages, okay, in terms of structure. Think about, how JSON messages are typically structured in API communication, okay? So that's what we used, and this is what pretty much I've explained, okay? One important note, this is just a baseline for you to get started. Then ideally you want to get some real world data, into the model, because it's it's going to be very domain specific. If you're a financial institution, your API payloads will look pretty different from a healthcare service provider. Okay, so it's for now open API descriptors. It's pretty much you have a lot of descriptors from online banks, from Google, Amazon, Microsoft, whatever. So it's kind of generic. But if you wanna, you probably have here your own formats that you wanna build on. So the training is pretty much easy. So once again, there's something very interesting you want to look at, which is called Keras. It's a Google framework, which pretty much abstracts you from the complexity of deep neural networks. I mean, you still have to know what you're doing, but the whole heavy lifting of creating a deep neural network is pretty much, kind of solved by Keras. Okay, so instead of implementing whatever, your code will be, instead of being 300 lines, it's going to be probably 10 or 15 lines. Okay, so it's more concise, more terse, but at the same time, you still want to know what you're doing. But it's much easier. So that's why I'm kind of using Keras. It also abstracts me from the specific deep neural network framework. So I can use Microsoft. I can use TensorFlow, like in this case. So you can use whatever is supported by Keras. You can use. It's not really like that, but there are some features which don't work as expected. So this is an LSTM. There's a whole discussion about why I'm using LSTM, but it's a type of, within neural networks, you have many different topologies. LSTM happens to be really good at processing at kind of natural language processing tasks. Okay, so it's pretty much the main, I think, feature is that it's able to remember kind of facts that happened before. So when you're processing a JSON message, it's a sequence, right? You want to know when you find a social security number, what happened before, because you have other JSON objects before that, right? And that is relevant, okay, because it pretty much tells you whether that's a typical JSON payload or not, okay? So that's what we're using with this. So the training works, as I mentioned before. Here it's a little bit more detailed, but it's vector embeddings is pretty much, let's call it it's like the native language of any machine learning framework. That's kind of the main representation, the core representation, because you cannot just paste or inject text just like that. You have to create something that pretty much is all numbers, digits, okay? So the model doesn't really know that it's dealing with text. So you have to pretty much map the text to something that can be processed by a deep neural network, okay? And there's, of course, deep neural networks, you can invest if you want 10 years, investigating that. There's so much. But I do believe that with not significant knowledge, you can start experimenting and kind of empirically, and then eventually, whatever is missing, you can focus on that or get training on that, whatever, or you can just learn it by yourself. Okay, so it's I think we are living a very interesting times in terms of that. The technology is more approachable, and I believe security people are typically the curious type of people. And I think if you're curious and you're willing to spend some time, you perfectly. If you look at the code, you'll see that the training piece is like it's like pretty much the core is like 10 lines, 15 lines of code. Okay, of course it's very basic. It can be improved significantly, but still, it's a way to get started. So. So once you have the model, right, you need to do predictions, which pretty much is, you get a JSON payload, and you want to make sure, you want to know whether that contains or not a PII. Of course, it's not going to be a Boolean response. It's not binary. It's going to give you a kind of a probability. Say, well, there's a 70% chance that this is PII. So it will depend a lot on what kind of data you feed, into the model. So it's very sensitive to that. And the other challenge is that you need a lot of data, okay? It's not just a few requests. And here's, I think I was able to generate about 30K, data points. So it's just enough. You can generate much more. There are different techniques to generate, more entries eventually. You can use add other APIs or whatever. So the prediction works in this way. You get let's assume you're in a live system. You get the JSON request message. You have to vectorize it. So transform it to this representation that it's AI friendly, let's call it like that. And then you say, well, now tell me if this contains a PII or not. And then you get this probability. Okay, so it's PII here. So this is pretty much why I explained. I'm trying to. I also describe that so for the records, so that this presentation will be available for download, so you can. It's still there. Okay. Things to consider. I said before, and this is just a baseline, something you can use to start with. It's not, depending on the data, on how you generate, and how the tool is configured, you're going to get better output or worse output, okay? So, and one of the key things here, and I believe, is how you generate this synthetic data, this kind of fake data, and the other thing is labeling. How do you know whether that request is really PII or not? For now, we're using a pretty basic techniques with trigger words and say, when we find some hint in terms of this could be PII, we just label it and say, well, this is PII. Okay, but there are many more sophisticated techniques you can use, and typically with natural language processing, it's a way you can analyze kind of the JSON payload and say, well, this might be PII, might contain PII. You can label that as PII or not, of course. The other thing is that, of course, a completely automated approach doesn't work. You typically want to make sure that any any labeling action that has been taken, or at least the ones you don't have a lot of confidence, is actually validated by a human being, okay? And say, well, this is actually wrong. So you can improve, or the person can say, this is okay, and this, or this is not, okay? So you're going to improve the quality of the model. On the other thing, once you get the model online, you want to make sure that, that model is updated, kind of in real time. Not real time, but at least, continuously. And that I think applies not only to PrivAPI, applies to any model, but the challenge here is, I think, the synthetic data set. If you have a real-world data set, I would go ahead and use that instead, or combine it, So let's see how much time do we have. Okay. Any questions so far? Okay. Yeah, go ahead. I can hear. Sorry, I have the fans, and it's like, yeah. I cannot hear it. Do you have a mic, or? I'm sorry.
Yeah, thank you.
Yeah, that's good.
Okay, so yeah, so far this is actually helping as far as I understood, for the leaking of the API itself. So if the API is leaking some other information back, but maybe there is another use case where there is, for example, I have my API is not leaking any PII, but it's probably I have a developer that just put a print statement, and that print statement is just logging PII in an Elasticsearch cluster or whatever. That is actually logging this information in a place where it's not supposed to be, right? In an insecure place that it's just somewhere else from the API. But based on this model, do you think that it would be possible to actually set up some integration to actually check if there is, because I know that my microservice or whatever, my API is actually connected to an Elasticsearch cluster, right? So do you think it will be possible to integrate this with that Elasticsearch cluster and just make the same kind of request, whatever, and just check if my PII is ending up in places where it's not supposed to end up?
So you mean in terms of, for instance, just checking or classifying maybe JSON messages that are not necessarily API requests or responses, could be documents or stored in a file server or something like that?
Any log, really. Maybe I'm logging this kind of stuff.
It's actually the demo I'm going to provide. It's not it's not going to use live API requests. It's just pulling the API request from a folder. So you can actually use pull these, it's just JSON payloads. So as long as you're using JSON, it's fine. If you want to, for instance, if you have XML, you will have to implement your own parser, okay? Because right now the only constraint I would say is that it has to be JSON, okay? But this JSON can be anywhere, stored anywhere, and you can. It's just an API. If you don't want to use the command line interface, you can just use it as a sort of library. You can just grab the model and just use Keras if you want to, and run the prediction wherever you want, how you want it. There's no restriction in terms of how you can run this classification process.
All right, thanks.
No worries. Yeah, sure.
Yeah? Right.
Yeah,
so I have another question. So in terms of the model itself, how does it deal with outliers? And how would you handle, for example, changes on the definition of the personal data if something in terms of policy changes to include more fields?
Yeah, that's a good question. As I mentioned before, let me go back here. You can there's a configuration descriptor for now where you can configure your what is known in we're using Python. It's called Faker. So it's pretty much those are like components, building blocks that you can use to generate fake data, and this can be customized. So if you want to generate social security number, you can use the social security number Faker or whatever. So if you have a specific data type that you want to handle, like let's say maybe a health record ID or something like that, you can build your own Faker. That's in terms of the synthetic data set, okay? And then if you have your own, let's say, open API format, and you wanna the model to know that, you can just, injected into the catalog. So pretty much the dataset generation process is pulling all these descriptors, from this catalog. So you can just add it to the catalog, and that way it will learn how your specific JSON message or payloads look like. Okay, so it's and then if you want to move, do something more sophisticated, you can just work at the labeling phase, and you can use natural language processing capabilities, and also introduce the human, okay, so that you make sure that the model has improves in terms of quality of the predictions. Okay,
Cool. Thank you.
So that's. Let me see if I have some time. I just don't want to. It's going to be, I have 3 more minutes. So let me see if I can switch. Actually, it's interesting. Let me see if I can. Okay, now I'm seeing what you're seeing. Okay, now let's. Okay, this is just there's a command which is a shell command. I'm gonna, it's Python. So what I'm gonna do, I'm gonna run the prediction task on top of a bunch of JSON requests that I have. Okay, and let me try to expand this a little bit. Okay, it's not that bad. So I'm going to run this, then I can show you. Don't worry about the warnings. It's typical in Python sometimes. So the important thing is here, the model is loaded. This has already been trained with generating predictions, and then the predictions are stored in a CSV file. Okay, so predictions are here. Okay, so we're gonna type these predictions. We can then see the JSON payload, but what is this saying is Magento, which has a lot of PII. Actually, it's considered PII. You see this one, it's actually a flag. It's saying, yeah, it's PII. And this is the probability, 92% that is PII. And then there's an Atlassian JSON, which is just a random, Atlassian, Jira, Confluence, just a kind of standard JSON with no personal data, and you can see that it says that it's not PII, okay? It's 0. And then the other, this is just a MISC also JSON. We can see some of these. Revolved is also mixed, and Alexa, as you can see, it's labeled as 1, 92% that it has PII. Let's see, for instance, Magento, okay? This is where this is coming from. See? Has a lot of information about first name, last name, region, California. So it's pretty much saying looks pretty much as PII, okay? And then we can see, for instance, let's see route, So kind of going back to one of the questions. I think the first question was whether you could use this for a general purpose task. Yeah, you can. This is just a route definition. It's not even. This is like a descriptor, and you can still run the PII process on top of that. Okay, and let's see, Alexa. This is also JSON, and while it's still considered that this has PII, it can be questionable, but it's seen that there is a user ID. It's technically, it's as you can see, it's a little bit anonymized, but still it thinks that this is kind of a confidential, which it just Alexa. It's not that bad that it's saying that, but answering the second question, here's how you can actually define all the fakers. I mentioned before. You can say, for instance, full name. You want to use the full name faker, but if you want to use a different one, you can implement your own on top of the fakers library. Fakers, it's a very known Python library. So if you're not happy with the default ones, and as you can see, this is really, really, really basic. I just enter, like credit card, just basic stuff. But this is, you should this should be much more complex in case you want to make it, real world. And it can pretty much also detect types, so you can also, based on type, you can have your own generators, and that's how it works. There's much more, but you can just go to the website, and there's more documentation on that. And then I've open sourced the whole thing, so you can also generate data. The whole data set generator is also open source. So it's everything is with an Apache license, so you can do pretty much whatever you want. You can sell it, do whatever you want with it. Okay. I think I'm done. Let's see if we have any question, but I think I have to leave room for the other speaker. Do we have a couple of more minutes, or yeah? Let's see if we can. If we have any question already.
Sorry, can I just...
Hello.
Yeah.
How's it going? You and other tools like this seem to be focused on like fields like names or postcodes or social security numbers. Like dependent fields can also be personal data. So where I have like a collection of information on its own that isn't like personal data, the combination can be identifiable.
Yeah.
How do you consider that in your product? Have you thought about it?
This is yet pretty simple. Think about like a sort of, I would say it's still like a prototype. But if you wanted to implement that, I would say it's part of the labeling process. So you can actually say, for instance, social security number is linked to this other field. Let's say it could be information about your whatever maybe the account, the bank account, or something related with your where you want your security, your money to go, for instance. So you could eventually link that. What I would work with, there's a toolkit called Snorkel. There's a whole branch in machine learning which is called data programming. Okay, so data programming is pretty much creating synthetic data sets, and there's this very popular toolkit. It's called Snorkel. I would really check it out. And then with that, you can actually do even something more interesting. You can apply natural language processing techniques, so it can be a little bit more fuzzy than just connecting, dependent fields. So you can say, well, I found a social security number, and this also term is close. Okay, it's close, and maybe it doesn't match SSN specifically. Maybe it's matched social security number. You can extract more semantics with NLP techniques. And once you extract more semantics, you can label your data sets better. Okay, so that's what I would strongly suggest. If you want to go kind of real world, you want to make sure that the labeling is very specific to your domain, your business. So, and I would strongly suggest using NLP, and Snorkel is a great way to start with that. Snorkel works really great. It's one of the upgrades we are thinking of, but right now this is just a prototype. We're working on a product on a different area, connected but different. But I would check that. It's called Snorkel. It's open source on GitHub. A great product. So I think the questions are open, but I have to leave. So I will keep answering questions. So I'm gonna leave it open until tomorrow. So just log into Slido, and PBD is the keyword. Okay, I'll try to follow up with everything. Any question you have. Okay, thank you so much.
For anyone that'd like to join us, we are doing an AMA with Elisa, the keynote speaker, in the community corner, but there is a coffee break now.